My talk today is going to be about the path to organization-wide adoption of AI. And in the last 3 years, I've met probably hundreds of different executives from enterprises in the financial services, manufacturing, and technology industries. And what I'm going to tell you today is about how to move from a single model in production into an organization-wide scale AI adoption. I started Beyond Minds 3 years ago after finishing my PhD in computer vision. And during that time, I was seeing that there is a huge value in AI, which I believe is quite clear for everyone today. The value, the business value of AI is enormous. The potential is huge. Some maybe will call it a hype. But the practice, the reality, there is a big gap there. And as you probably know, and if not, the industry standard for taking a solution in AI from the lab into production is somewhere between a year and a half. Not only that, after the solution is in production, the TCO caused by maintenance, by support, by retraining, by deployment, by re-implementation is enormous. Most of the solutions, around 90%, doesn't make into production, and those that do reach production are not profitable. And last, there is a complex scale issue. While most of the organization only starting to bring AI to production, maybe less than 3% are really adopting AI at scale. And that's where I'm going to talk a little bit more today about that scale complexity and how to solve the long time to value and the profitability problem at scale, at an organization-wide level. So let's stop for a second and start with looking at the path to production. Okay, and the standard way to do AI productization today is starting from bringing a center of excellence, team of data scientists, AI researchers, ML engineers, etc., and take a problem, collect data, train the model, achieve 95% accuracy, and be happy. And then you go and try to take that in production. And unfortunately, that specific experience of building a great model in the lab and bringing that to production is way more complex than the building in model itself. I think maybe it's exaggerating to say that creating the model is a solved problem, but it's not far from that. It's starting to be more and more democratized. More and more people have the knowledge of building models and training new solutions. But taking these models and bring them to production, that's a completely different story. And it involves much more than a model. I put here 14 different elements. So altogether, we have 15 elements that are needed to bring a solution to production. And I'm going to step a little bit deeper into this list and show you where the complexity and problems come from. Now, before I'm diving into that, the main message that I want you to remember today after my talk is that this path between the lab to production is probably the most challenging and important problem to solve in your organization if you want to adopt AI at scale. If you want to adopt maybe one problem, maybe two, maybe three, don't go there. But if you want to be a leader in the industry and adopt AI at scale, organization-wide, you need to take deep dive into that problem. So let's start. We have trained an AI model, and we want to put it in production. The average time that I found standard is 6 weeks to train a model. You have a data set, you have a business goal, you worked with the product team. It will take 6 weeks around to have a ready to deploy model. But then you start to handle the requirements and the needs and the constraint of the production environment. For example, how do you deal with real-time inference? And you can take different type of problems. I'm talking in general about AI, but you can think about anti-money laundering, defect detection, predictive maintenance, claim assessment in insurance, churn prediction, sales prediction, you name it. Take whatever problem that you have in mind, that you have experience with AI, to bring color into that example. And what I'm showing here based on lots of different use cases that we have built and helped deployed and solve problems in the last 3 years. So to handle real-time inference, you need to deal with data injection, and you need to deal with APIs, and you probably need also to deal with security elements and compliance, right? And then a different problem comes, right? You need to verify that the model actually works, right? And how you deal with the quality of the data that you're going to handle in production. That could be very different, the clean and safe data set in the lab that is static versus the dynamic data that you have in production. So you need to work about the data quality or the data mismatch between train and test or between the lab and production. And you need to work maybe with small label data if experts label are needed. Okay, and then you need to add compression and optimization of the problems because you don't have 10 GPUs or very fancy hardware or huge cloud resources in order to take that into production. And it could be that you have, but with 10 GPUs, the use case or the application won't be profitable. The cloud cost will be much more than the actual ROI from that use case. And in many cases, you don't even have labels. Take predictive maintenance, for example. You are trying to predict anomalies, failures, right? Maybe you have 3 failures a year versus millions of data points. So you need the ability to deal with smart annotations or simulating data. And then you have the problem of noise and the dynamic of the data and what's happening in production, right? So you need to be able to test yourself again and again and again in production. I think there is a famous say about AI that when it fails silently, like many other systems. But in AI, it's very, very dramatic. If you will build a classifier to distinguish between a cat and a dog, and you will propagate an image of a giraffe into that classifier, it will say that it's a dog, probably. And not only that, it will say that it's 95% sure about that. That's a classic failure of deep learning, of machine learning. That's happening all the time. And you need to deal with different mechanisms to handle that type of problems. Test suite is one of them, right? Having these filters that are screening the data, that understand that only data that within the distribution is following into the model. And then you need the ability to retrain, or what we call continuous learning, right? It's not only about training with the model in the lab. You need to face what's happening in production. If the data is changing, the model should change as well. And the data is changing almost everywhere, almost in any application. Then, if you are in financial services or insurance or many other applications, trust, transparency, explainability, all of these factors are critical. The risk department or the compliance or the regulator won't let you feel free to just take your ununderstandable AI model into production. And then version control, right? That's a very classic engineering problem of controlling what's happening in production and controlling the versions. But when it comes to AI, you need to do version control for the code, but also for the model itself and for the data. What data was used to train this model? Can I retrain it exactly as it is when the regulator will come and ask me how that was trained? Or when someone internally will ask me? And then you need monitoring. So you can bring lots of different ML ops or monitoring solution and combine that into your overall solution. But monitoring is critical to understand that what's going on under the hood, that it's safe, that it's work well, right? And then scale, right? Okay, you trained the model, you brought all the components, you probably had a team of 20 maybe to deal with all these components. Now, maybe I'm exaggerating with all 15 components, but it's somewhere on that range, right? It could be that in some application you will have only 5 components, in other you will have 10 components that are needed, but overall you need a lot of different system components to take AI into production. And scale is a very interesting element because it requires to generalize elements, right? And to those of you who are familiar with software engineering, what's happening today in software engineering mostly is that you are not trying to do over specifications, right? You are trying to do only what is needed to solve the problem ahead of you. And you solve one problem and a second problem and a third. And after you solve 3 problems, you do what we call a refactoring, right? You want to start and generalize. And that's exactly what I think we need to do in AI as the infrastructure problem. Okay, so the last element is support that clearly is needed. And unfortunately, after bringing all these 14 components into place to wrap the trained model that took us 6 weeks, we end up with 18 months of development with a team of 20, with huge cost. Now, not only that, the infrastructure that we have built here is so specific and so tailored to the problem that it won't be reusable for the next use case. So that brings me to the biggest question of my talk today. How to deal with this orchestration problem? How to move from data-centric approach into this production-centric approach? Can we build these 14 elements first in a system way that can wrap any model after that? Think about that. Instead of building a model and then bring all the production components into place, let's build the 14 components in a generic way and then bring model after model after model. And we already said that building a model is starting to be democratized. We have enough talent today in 2021. We have enough knowledge. There is infinity amount of open source to do that. So it's possible. But building that platform, if you want, or infrastructure, is a different scale and complexity of a problem. But it's possible. And in the last 3 years, across hundreds of companies, I saw few that done that. And I think today we see also different platforms, tools that can help significantly in that orchestration problem. Let me give you one critical example out of this 14, which is the train and maintain loop. It composes of different components in that story, but I think it's a very good example to see how things can be generalized. Okay? Most of production problems, of AI production problems that contain human in the loop or mission critical or business process are dynamic. They cannot be trained, deployed, and evergreen system. They need to be maintained. They need to be retrained. They need to be redeployed. And that simple loop of labeling, training, evaluating, and then deployment, monitoring in production, and feedback collection from the operator, from users, and repeating that cycle is a must-have. Let's take an example. We want to detect fraud in financial services, in transactions monitoring. That's clearly a dynamic problem. The fraud of 2020 is not the fraud of 2021. That model must be retrained. We have new labels coming from users, from people that call to the support and saying that they had a fraud, or from people that are calling and saying that's not a fraud, that's a real transaction that the automatic AI blocked for me. That must be retrained. And that's not a singular example. Take defect detection in manufacturing production line. You will have exactly the same problem. Something have changed in the acquisition, someone changed a light bulb, someone changed the supply chain. You have new defects. The image looked different. Something is changing all the time. I hope Gina Chang will excuse me for bringing a citation from DHL. That's from a BCG and MIT Sloan survey they done last year around 3,000 companies. And she's saying that the worst day for AI is the first day because the algorithm gets better over time. There is always a loop to ensure that we capture feedback. This feedback is essential to help the AI identify a palette that can be stacked for some reason, such as the fragility of its contents. Now, that's exactly what I just told you, right? And you see that in many, many different applications and areas. And the successful companies in adopting AI are bringing that feedback, these continuous learning elements. This is from the same survey that I told you. And what you can see here is a correlation between the feedback mechanisms and success or profitability as they measured. And use cases or companies that deploy 3 different feedback methods into their AI strategy have significantly more chance to achieve profitability with AI. So let's dive a little bit deeper into some components that are interesting around how to bring AI to production and what things to more emphasize when you're building this infrastructure problem. Take sustainability, for example. That's very related to what I just told you about the infinity loop of train and maintain, etc. Keep these models that you have built on the rails, right? How are you going to deal with data that is going to be dynamic? Can we monitor and detect when the data is drifting or changing? And if we can monitor that, can we collect that data? Can we send to the human in the loop these examples, right? I mentioned claim assessment before. Let's take claim assessment as an example. We want to automatically decide if to reject or accept an insurance claim. Now, clearly, no AI solution in the world will achieve 99% accuracy, but that's the business requirements, okay? Let's assume that the model can achieve 90%. That's required from the solution to be able to combine the human in the loop. The simple cases can be done automatically with the AI, but the more complex, non-repetitive, out-of-distribution cases should go to the human. You need the ability to cut and split with a confidence or uncertainty thresholding, right? And the threshold is going to be dynamic because the data is dynamic and the out-of-distribution is dynamic, and you're going to retrain the models over time. That mechanisms are critical if you want AI adoption at scale. Otherwise, you need a team for each model that is being deployed. Let me give you another example. In the last few months, I have been working with a company that is trying to take a sales prediction problem into production. Unfortunately, they have more than 30 different instances of CRM. So they build a model for one instance. It took them a few weeks, not too drastic. But now there are people that all they do is maintenance. They have to retrain these models every week with the new data that comes, to validate, to make sure that it works, to deploy. You need automatic deployment. You need CI/CD for the models, maybe CT for continuous training. You need cloud services to support that. You need Kubernetes elements to deploy that on a different scale levels. And then let's talk about ethical behavior. Bias is a critical element that comes again and again in many different use cases. Can you have the right mechanism to do bias mitigation in your models? Make sure that the data that you are training your model won't be biased. And I'm not talking about necessarily about complex bias as gender. There are bias everywhere in any data. Even if we take defect detection, if that's defect or not, the data could be biased. It could be biased towards non-defects because we have 2% of the data that is biased. Or it could be that there are rare cases that are not well represented in the data that need to be mitigated systematically with different steps. So my take-home message for you is that machine learning at scale is an infrastructure problem. It's much more than building a model. It's much more than building a system. It's about having the right components generalized and enable scale adoption of AI. And then, with that infrastructure, the business value from AI that is a hype currently, that struggle with the long time to value, with the huge costs and the complexity of scale, can become reality. You can have quick time to value, right? Because you have the system and all you need to do is building new model. And that can be achieved with a time scale of 3 months per new model. You can have a significant reduction of the TCO because the maintenance become a scale problem. You don't need more and more people to maintain more and more models. And that can scale across the organization. It's not something that you do in one department and when you go to the new use case in another department, you need to rebuild again. Thank you.
Okay, thank you, Roey. We've had loads of questions come in. Clearly, AI is going to be a hot topic throughout this show. But I won't bombard you with all of the questions. Just a few to pick up on here. What's your view on retaining manual control in AI solutions?
Critical. Human in the loop is critical. I think that most of the applications, if you want really to succeed with, you need the ability to combine human in them. And I think that requires different research problems like confidence estimation, like how to collect feedback from users, UI to support that. So I think it's super important.
Okay. And when should enterprises rely on a fully automatic solution, and when should they consider keeping a human in the loop? I know we've sort of touched on that.
Well, that's a question that cannot be answered at scale, I think. It depends on the application. But definitely in the pre-assessment, which, by the way, I think it's companies that I see know how to do that quite well. But you need to assess if it will be profitable when the AI will work. Take predictive maintenance as a classic example. Most predictive maintenance applications won't be profitability. It won't be good to replace periodic maintenance with predictive maintenance because a failure won't be $1 million.
Okay, well, just one final question. Do you feel the potential for growth and sustainability in AI is in the adoption of the production-centric model that you mentioned there?
I believe so. I believe so. I think it's a good way and good angle to bring the sustainability element and definitely this adoption wide. So if you're an edge company that try to be a leader, which probably a lot of companies are, this element is very, very important.
Okay. All right, everybody. Another great session. Thank you, Roey.
Thank you very much.
Thank you.